All right, our third one is phosphorus, right? So we're going to start with the electron dot diagram. Remember, we have to start always with our periodic table, right? So one of the good things about this week is our drawing gets a little bit easier because all we're doing is we're just drawing the electrons in the outermost ring, right? So phosphorus is right here, okay? So remember, to count the valence electrons, all we're doing is count the tall columns. So 1, 2, 3, 4. It's in the fifth tallest column, right? So P would have 5 valence electrons. So I'm going to put 5 electrons around it, right? So from here, right, we have to ask ourselves, so obviously I'm going to take a screenshot, put it there. Now we're going to ask ourselves, is it a giver or taker of electrons? Remember, it's going to want to get to one of two numbers. It's going to have to get to 0 or it's going to have to get to 8, right? So we have to ask ourselves, okay, in order to get to 0, it's got to give away 5 electrons. Or if it's going to get to 8, it's going to have to take 3 electrons. Well, 3 is a smaller number, so it's much, much easier to take 3 more electrons than it would be to lose 5 electrons, right? So phosphorus is going to be a taker of electrons, right, to be happy, right? Now, remember, right, whenever electrons are given or taken, the number of protons and electrons are not the same anymore, right? We've been talking about how it's been neutral. Atoms are neutral, 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 right? The protons equal to electrons, okay? Now I have 3, right? 3 different amounts of our electrons, right? So again, we have to ask ourselves, is it 3 plus or 3 minus, right? Since it gained 3 negative things, it would be a 3 minus. Remember, the minus sign is not subtraction. It is a symbol for the electron because an electron is negatively charged. So we can say that in order for phosphorus to be happy, it's got to have 3 more electrons. Okay? All right.